In this video, I introduce a neural transducer for automatic speech recognition. Sequence-to-sequence models make an input sequence to output sequence that is a condition on the input sequence. A neural transducer makes the incremental predictions as more input arrives. Unlike sequence-to-sequence models, the neural transducer computes the next step distribution condition on the partially observed input sequence and the partially generated sequence. However, its limitation is alignment of output samples to input sequence because they are unavailable during training. This is architecture of a sequence-to-sequence model. This is architecture of a neural transducer model. Each transducer only works on a local region. For example, this transducer uses the state of previous transducer and output from the encoder to generate outputs here. The encoder receives the input sequence X at each time step and converts it to a hidden state vector HI. Suppose that Y1 to S is a corresponding target sequence, W is a block size, and N is number of blocks. The transducer produces a sequence of K outputs, Y I to Y I plus K, padded with the end symbol. The transducer maintains its state across the blocks using recurrent network and produces output in block B, for example, a subsequence ym plus 1, and ym plus 2. Attention mechanism is used to relate each output to the input sequence. For example, if we use attention mechanism here, we use S and H to calculate A, and then we use A and H to calculate this contact vector C. Otherwise, we use this S and H to calculate this C, and then we use C to calculate S and H. Suppose that Y is a set of all alignments of output sequences Y from 1 to YS to the input blocks, and EB is the index of the last token in Y in block B. Our task is to compute the probability P of the output sequence Y conditioned on the input sequence X. To do so, we first compute the probability of seeing output sequence Y by end of the block B here. Each term in the here is a joint probability of outputs in block B. So we can use the chain rule to express this joint probability as a product of conditional probabilities of Ym. Whereas the conditional probability P here is computed by the transducer using decoding of the input X and the label prefix Y. Suppose that a block B has indices from M to EB. The transducer computes a conditional probability of Ym is updated by using these equations here, where this F context is the context function that denotes the correlation between the state Sm of the transducer and the hidden state H of the encoder. If the encoder is RNN, H is a function of input X, the objective is defined as a probability of output sequence Y given the input sequence X here. For more details, please check with these references. Thank you. Bye.